Cool. All right, we'll break this into two parts because I don't want to talk too long, and I'm just mindful you guys probably would want to break. Let me just find which ones I want us to do as practice. Ah, found it. Okay. So I want to do some practice conversions between name and drawing. So that way you guys can kind of learn the process of how to name organic molecules. I'll just focus on the alkanes for now. So that way they stay quite simple, and then I'll add on some extra bits and pieces. So the nice thing about organic chemistry is the first bit of it is going to be quite complex because there's lots of rules we have to know about naming. And once you guys know the foundation of it, it's then really easy to then know how to name other stuff outside of the alkanes. So let me draw an organic molecule. It has 1, 2, 3, 4, 5 carbons. And on carbon number 3, it has a branch. And then let me put in all the hydrogens. So we're naming this molecule first. We good so far? All right, I would suggest you write this down. Oh, can you guys pile the weekly check-ins? I'll get them up later. I highly suggest you write these things down because this is a pain otherwise. All right. Some things you guys should hopefully notice when you're looking at does anyone need paper, pencil, notebook? I can get you a notebook. Yes? Okay, let me get you some stuff. Let me just pause the recording. Okay. So, ready? Okay. When you're doing organic molecules, the first step, if there's, I'm going to say, trying to say, I'm just going to keep it simple. The first step is you need to find the longest chain, because the longest chain is going to be your parent chain. So if I was to go through and count them, and I start at this end, so a parent chain is a continuous chain. So if I went here, I'd go 1, 2, 3, 4, 5. That length of chain is 5. If I go in the other direction, 1, 2, 3, 4, 5, that is also 5. So those two are so far long, the same size. If I go down this way, I would have 1, 2, 3, 4. 4 is smaller than 5, so that is not my main chain. 1, 2, 3, 4, again, 4 is not bigger than 5, so that is not my main chain. So this one here is the longest chain. That's going to be my parent chain. So that's step number 1, find the longest chain. I should also add that when we start looking at functional groups, you're going to find the longest chain with the functional group. But we'll cover that next. Functional. But we're not going to worry about functional groups at the moment. We're just going to think about alkanes at the moment. All right. So we've identified that this straight chain here is the longest chain. It may not always necessarily be the one that's drawn straight like that. It could be one in a little corner, and I'll show you what I mean when we do some other examples. Please stop flicking. All right. The next thing we have to be mindful of is now that we've found the parent chain, we need to number it, and we need to number it only once. Now, when we are doing this, again, some things to keep in mind is we want to number to create one of two things. The first thing that we want to do, if we have them, is to give the functional group the lowest number. Or possible numbers. Again, I'll talk about that later in the second part of the notes. I don't want you guys to worry about that now. If there are no functional groups, then you are going to give it to the branches, and you want the lowest possible combination for the branches. So that's our second kind of thing to keep in mind. Are we okay with that so far? All right, let's look at our organic molecule and let's number it in both directions to see if it affects this guy over here. If you think ahead, you can already see that it's not going to, but let me just show you. So if I number it going in this direction, that's carbon 1, that's carbon 2, that's carbon 3, that's carbon 4, that's carbon 5. If I number it in the opposite direction, that's number 1, that's number 2, that's number 3, that's number 4, that's number 5. Now I am only concerned, because there's only one branch here, about this guy over here and what that number is. So I want to give that guy the lowest number possible. If I look, both of them are 3, regardless of which way I number the molecule. So it doesn't matter. There's nothing else attached to that organic molecule that's going to then influence that. So I don't have to worry about it. I can go ahead and start naming it. I notice here that this is 1 carbon, so that would be a methyl. I notice that in my parent chain there are 5 carbons, so that would then be pent. Are we good? All right. So when we are naming things, we name them in alphabetical order. There's nothing else to worry about with the methyl. So we just go 3, methyl. The 3 indicates that this is on carbon number 3. The methyl indicates the length of that chain. So this is 1. And then I do the parent name. I do pent. And in this case, this is going to end in an A-N-E ending. Pentane, because this is telling us that this is an alkane. So that is known as a suffix. Now these suffixes can change depending on the functional group we have. And I'll show you guys that later. I just want you guys to focus on the alkanes, because that's the base foundation. Are we good so far? Shall I keep going? Yes? All right, next example? Okay. I'll put them all on new sheets of paper, so that way if you want, you guys can grab them as I go. All right, here's my next example. This one now only has 4. 1, 2, 3, 4. And I see that there's a single carbon on carbon number 2. So let me draw that out. Just FYI, the way I'm figuring out how many hydrogens to add depends on how many things are bonded to that carbon. So this N carbon is bounded to 1 carbon, so that means I have 3 more spaces to fill, thus I need 3 hydrogens. This middle carbon here is attached to this carbon here, 1, this carbon here, 2, this carbon here, 3, so it only needs 1 hydrogen. Carbon always needs 4 bonds. This carbon here is attached to that carbon there, that's 1, that carbon there, 2. So I need 2 more hydrogens to get to 4. So the magic number with our carbons is we're trying to get to 4. Are we okay with that so far? All right. Again, let's go through and figure out longest chain. So I can go here, 1, 2, 3, 4. I can go backwards, 1, 2, 3, 4. I can go this way, 1, 2, 3, 4. Or I can go this way, 1, 2, 3, 4. So regardless of where I name it or start the naming, it's going to be 4. Now, if I decided to name it going 1, 2, 3, 4, you see how I have a methyl attached. So it's 1 carbon branch. If I named it this way, 1, 2, 3, 4, it still has a methyl attached. So regardless of which way I name it, which way I number it, it's still going to result in the same name. Does that make sense to everybody? Okay. So let's then see our naming options. I personally, if I have it like this, I'll just use that as the parent and look at those as branches, but you can do it the other way. So if I was to do it like that, 1, 2, 3, 4, or this could be carbon number 1, still would work. If I go this way, I have 1, 2, 3, 4. Now in this case, where I do the numbering does matter. So when I went from left to right, you see how the methyl is attached to carbon number 2. If I went right to left, now it is attached to carbon number 3. So I have a choice now what number I assign it, and I'm going to assign it the 2 because that is the lower number. Now, since I've set that as my numbering, if there was anything else attached to this carbon, then it would be based off of this numbering pattern. So we can only number it once. So this would make this a 2-methyl, because once again, we have 1 carbon. It's attached to carbon number 2, and there are 4 carbons attached to it. So 4 is bute. And then we're going to go A and E as our ending, because we are still dealing with an alkane. So those are my basic examples, and now I'm going to show you a complicated example. Questions so far? Are we okay? Okay. All right, here comes the doozy. All right. 1, 2, 3, 4, 5, 6, 7, 8. What do I need? Need that. 5. I'm just going to do it in a different direction just so you guys can see what I mean. That should be a 2, sorry. All right, here's my next example. Let me fill in my hydrogens. So you see how this one has already 4 things? 1, 2, 3, 4. So there's no hydrogens on this guy. All right. Look at that monster of a question. All right. We okay? Hopefully everyone got that. And now everyone's like, what did you do? You went from 0 to 60, miss. Yeah, I probably should have put an easier one in there as an in-between. But that's okay. You guys will see what I really mean with this one. All right, get started. You guys copied that down? You guys still need it too. All right, so just be mindful. This has 8 carbons. This carbon here has a 3 chain attached to it. That one has a 2, and that one's a 1. All right. Shall I go? Okay, now we need to go through and figure out the parent chain, so we're going to be doing lots of counting. So if I was to go straight, that's 1, 2, 3, 4, 5, 6, 7, 8. If I was to go from here to here, it'd be 1, 2, 3, 4, 5, 6. 6 is smaller, so we're not using that route. Let's try this route. 1, 2, 3, 4, 5, 6, 7. 7 is not bigger than 8. 1, 2, 3, 4, 5, 6. Again, 6 is not bigger than 8. We can go this way. 1, 2, 3, 4, 5, 6, 7, 8. That is also an 8 chain. Okay? If you guys notice, it doesn't matter if I use this as my parent chain or this as my parent chain, because either way, the branch is going to have a 3-carbon branch. All right? Do you guys want me to do it from this way, or do you want me to do it from this way? Does it make a difference? It doesn't make a difference in the naming. I just wondering if you guys seeing it would make a difference to you. Just the straight one or the crooked one? Okay, I can do the crooked one. It's going to result in the same result because you see how this is 3 and that's 3, so it doesn't make a difference. All right, so let's go through and number it. So if I started from this one, I would go 1, let me go yellow, sorry. Try to keep with the color code. All right, if I went this way, 1, 2, 3, 4, 5, 6, 7, 8 is that way. If I went in the other direction, it would be 1, 2, 3, 4, 5, 6, 7, 8. So what I want to do is I want to look at all my branches, that one, and that one, to see what the possible number combos are, because I want the lowest possible combination. So if I went with the yellow pathway, I would have a 4, a 4, and a 6, so that would be 14. If I went with the red pathway, I would have a 3, a 5, and a 5, which would be 13. Do you guys see how I got those numbers? Or do you want me to repeat it? So if I use the yellow pathway, the propyl, which is what that is, and the ethyl would be on carbon number 4. Those are the 2 4s. The methyl would be on carbon number 6. So I would have 4, 4, and 6 if I was doing that combination. That equals 14 when I add it up together. If I use the red pathway, the propyl and the ethyl would be on carbon number 5. Those are the two 5s there. And the methyl would be on carbon number 3. 5 plus 5 plus 3, 13. So this is the shorter combo. Yep, let me just pause the recording. So that is a better combo. Agreed? Okay. So what that means is that the methyl is going to be assigned a 3, the ethyl is going to be assigned a 5, and the propyl is also going to be assigned a 5. And then my longest chain is the 8 octane. So when I go now to put this all together, I'm going to put this together in alphabetical order. So E is the first letter out of those 3. So we call it 5-ethyl, comma, and then M or P, M's next. So 3-methyl, comma, and then last one, 5-propyl. And then parent chain is oct, and then ane, because we're dealing with an alkane. That's how you name that bad boy. Cool? Make sense? All right. I have one more example, but I don't think we necessarily need to do it because what I wanted to do in that example we've done in this one, which is name it from this other sidechain thing. Do you guys want some time to digest and practice that? Yeah? And then I'll go through functional groups? Okay, let's do that. Give you guys a break.